Alright, this video is for those students that were not here when we did the Radian and Degree Measure notes. So if you go into the course, and you go under Trig Basics, it's the very first one, and the notes are the very first one. Alright, so radian and degree measure. So radians are just another unit of measure for angles. So if you look on the first slide, you'll see that, for instance, 90 is pi over 2, and so on and so forth. So, you don't really need to worry about this up here, it's just math jargon, but if you look down here, if this is our angle, this point here will be our vertex. This side here will be our terminal side. And this side here is our coterminal side. Alright, so terminal is where it starts, coterminal is where it finishes. Now, you won't really see it normally as a static image, but you will see it on a coordinate plane. So the vertex being the origin, this side being the terminal side, and this side being the coterminal side. This is how you would more frequently see it. And then right here would be your angle. Okay? So if we're moving along, you're also going to have positive and negative angles. So this one here is positive because it is going counterclockwise. Okay, and this one here is going negative or clockwise. So the one on the left is going to be a positive angle, so like positive 45 degrees. The one on the right is going to be something equivalent to negative 45 degrees. Alright, so radians. 1 radian is the measure of a central angle that intercepts an angle equal to an arc equal in length to the radius of the circle. Basically what that's saying is that a radian is just a unit of measure. The important thing that I want you to get out of this is that one rotation or one revolution around the circle is 2 pi. So if you look at this, if I go all the way around the circle, that's going to be equal to 2 pi. Alright? So here are some common angles in radians. The first one is obviously going to be 0. Alright, so it doesn't move at any portion around it. The next one is if I split this into fourths. So 1, 2, 3, 4. So you would know it as 0, and then if it comes all the way around and is 2 pi, that means halfway around is pi. Halfway between 0 and pi is going to be pi over 2. And down here, this would be 3 pi over 2. So how you can think of it is 0, 1/2, 1, 1.5, 2. Alright, so this is when we split it into quarters. And the other common one that we do is we split it into thirds. So up top, we're going to split it into thirds, and down below, we're going to split it into thirds. So then this would be 0, pi over 3, 2 pi over 3. This one's just going to be pi, so I have 0, 1/3, 2/3, a whole, and then this is going to be 4 pi over 3, 5 pi over 3, and then when it comes back is at 2. So it does one full rotation in thirds. The next one is splitting it into sixths. So this one's going to be a little harder to draw. All right. So you know that you start at 0, pi over 6. This one here is going to be 2 pi over 6, but a nicer way of writing that is just pi over 3. And then this you would write as 3 pi over 6, but a nicer way of writing that is just pi over 2. Then you're going to have 4 pi over 6, which just reduces to 2/3, 5 pi over 6, and this would be 6 pi over 6, which just reduces to pi. 7 pi over 6. This one, instead of putting 8 pi over 6, I'm going to put 4 pi over 3. This one here, instead of putting 9 pi over 6, I'm going to put 3 pi over 2. Here, I'm going, instead of putting, so we're at 9, 10 pi over 6, I'm going to put 5 pi over 3. This one here is 11 pi over 6. And the last one, instead of putting 12 pi over 6, I'm going to put 2 pi. All right, so notice that they go up by 1/6, but notice that it will reduce to 1/3 or 1/2 at some of the stages. The last two just that I like to go over, we kind of have already talked about it, would be 0 and pi, and then coming back to 2 pi, and then just having one full rotation being 2 pi. All right. Just to review the quadrants, we know that this is quadrant 1, 2, 3, and 4. All right. So we know that if this is going to be 0, this is going to be pi over 2. So any angle between 0 and pi over 2 is going to be in quadrant 1. We know that this is pi, so anything between pi over 2 and pi is going to be in quadrant 2. Down here we know that this is 3 pi over 2. So any between pi and 3 pi over 2 is going to be in quadrant 3. And any between 3 pi over 2 and 2 pi would be in the last one. Now the same goes for negative. So we could have negative pi over 2 here, negative pi, negative 3 pi over 2, and this could also be negative 2 pi. All right, sketching and finding the coterminal angles. So previous to this one, we're going to sketch where it is. So whether it's here, whether it's here, or here. So 13 pi over 6. I'm going to look at just this 13 over 6. This is equivalent to 2 and 1/6. And we know that 2 pi is one full rotation, and then pi over 6 is just going to be a little bit into the first quadrant. So I know that I'm going to go fully around and then a little bit more, and that's where my angle is going to be. So that again is I went fully around and then just a little bit more into the first quadrant. 3 pi over 4, so we know that that's going to be somewhere between 1/2 and 1/2. So my angle is going to go to about there. And negative 2 pi over 3, so I know that's actually going to go the opposite way, or clockwise. And I know it's going to be somewhere between 1/2 and 1/2. So it's going to be somewhere down in this bottom quadrant. So in here. Now, converting between degrees and radians. So I'm going to set up a ratio and show you how I get these formulas. So we know that there are 360 degrees, and that's equivalent to 2 pi and dealing with radians. So here's our kind of our ratio. So 360 goes to degrees as 2 pi goes to radians. What I'm going to do now is I'm going to solve for radians. All right, so I'm going to solve for this here. So I'm going to start by multiplying both sides by, actually, what I'm going to do is I'm going to start by flipping the inequalities. So I'll show you what I mean by that. I'm going to write degrees over 360 equals radian over 2 pi. And then I'm going to multiply both sides by 2 pi. And that's going to get radians all by itself. Okay. So that gives me 2 pi over degrees times 360. Now I can simplify here, and then my final equation is going to be pi times degrees all over 180. And that's going to give me my answer in terms of radians. So this is one of my formulas. Now, I'm going to do the same thing, except I'm going to solve for degrees this time. So I'm going to take this same formula, and this time I'm going to solve for degrees. So I'm going to start by flipping them again. And I'm going to multiply both sides by 360 to get degrees equals, ooh, I forgot to switch these over here, radian over 2 pi. Okay, and that's going to give me 360 radian over 2 pi, and I'm going to have the same 180 over 1. So my final equation is going to be degrees equals 180 radian over pi. So these are the two formulas. You don't necessarily need to know how I derived it, but you do need to know these two formulas that are boxed. Okay? So this is how you can convert from one to the other. What I'm going to do is I'm going to copy this top one here. And anytime we have to convert from degrees to radians, I'm going to use that. So here we have to convert from degrees to radians. So this is the formula that we'll be using. So what I'm going to do now is I'm going to do this times pi all over 180 equals. So I'm going to leave the pi out. I'm not going to actually multiply this top here. I am, however, going to reduce 135 over 180. So if you use your calculator, trying to get mine up here. So if I use the calculator and I do 135 divided by 180, you are going to get a decimal, but if you use that math frac button, you will get 3/4. So this is going to convert to 3 pi over 4. So you will need to use that math frac button. All right. For 540, it's the same thing. Pi over 180. And when you reduce 540 over 180, you're going to end up getting 3. So 3 pi will be your solution here. The last one, 270. Notice that you still have that negative, so you are going to leave that. When you put negative 270 over 180 in your calculator and reduce, you're going to get negative 3/2. So you would write it as negative 3 pi over 2. Okay, so now the last slide is going to ask us to convert from radians to degrees. So I'm going to go back. I'm going to copy my formula. So this is the formula that we're going to be using. All right, so I'm going to be timesing it by 180 over pi, essentially. It's the same thing because if your radian's a fraction, that denominator would just come down. So you can just think of it as timesing it by 180 over pi. You'll see that the pi's will cancel out and you're left with 180 over 2, which just reduces to 90. Please make sure you put the degree sign, however. Okay. Do the same thing here. 180 over pi. The pi's will cancel. I'm going to do some other cross canceling. So 180 over 2 becomes 90. 9 times 9 gives me 81. And with the 0 gives me 810. And lastly, 2 pi. We actually know that this is one full rotation, so we know our answer should equal 360. But let's just check to make sure we're doing it correctly with our formula. All right, pi's cancel out, and we do, in fact, get 360 degrees. All right, feel free to watch this numerous times to make sure that you understand all the material, or come to see me before or after school to make sure you get it. Your assignment, however, if you go back into the iTunes U, number 1 was the notes that we took, but number 2 here is your practice. Okay? I will tell you right now, please do not do problems 13 and 14. So we're not doing problems 13 or 14. Also, another note for 5, 6, 7, and 8. There's a little bit of problem solving involved here, but please make sure that for 5 and 6 that your answers are in terms of degrees, and for 7 and 8 your answers are in terms of radians.